jee+class.com.
Okay, next preparation method is by decarboxylation of geminal dicarboxylic acid. Geminal, gem means geminal. Okay, complete name is geminal. So here both carboxylic acid will be on the same carbon. This COH is also on same carbon. This COH also on same carbon. So such type of carboxylic acids are called as a geminal dicarboxylic acid. Okay, so whenever you heat, then out of one of them, like this I am taking CO2, so this will be evolved as a CO2. So this hydrogen will go and attach here. So earlier it was RCH, now it will be one more hydrogen added, that is converted to CH2. Okay, so this is what preparation of monocarboxylic acid, but by using the geminal dicarboxylic acid. Okay, this is very rarely used method. It is not much used because already carboxylic acid is there. Okay, so next, formic acid is prepared from oxalic acid. Oxalic acid, that technique I told you, Ohm's gap. Okay, Ohm's gap, oxalic acid. So starting, there is no CH2 here. Understood? 0 CH2. There is only 2 COH group and total 2 carbon atom. 3 carbon with 1 CH2 like this. 4 carbon with 2 CH2. 5 carbon with 3 CH2. 6 carbon with 4 CH2. 7 carbon with 5 CH2. Okay, so these are the Ohm's gap. Sorry. Ohm's gap. Okay, you will remember like this. These are the dicarboxylic acid, oxalic, malic, succinic, like that, glutaric, adipic, pulmaric. Okay, so these are the, now when you wanted to prepare formic acid, okay, then what you will do? Simple, take oxalic acid and heat up to 110 degrees Celsius. So when you heat up to 100 degrees Celsius, this CO2 is evolved as a, so this CO2, it is came out. Then this hydrogen will be attached here. Then it will form as a HCOOH. Okay. So that is possible only in case of the glycerol 110 degrees Celsius. But if it is in absence of glycerol, you have to heat to very high temperature. Then this part, see very carefully you have to write. I am writing it here so that you can understand easily. So this will be the C double bond OOH. Okay. Then this will be C double bond OOH. Okay. Now see here, this will be H2O. So one product is what? H2O. And another product is what? CO. Another product is what? CO. And third product will be CO2. Third product will be CO2. So CO2, CO and H2O. These are the three products. Okay. When you use, when you heat in absence of glycerol. If it is heated in glycerol only, you will get formic acid and CO2. If you don't use glycerol, you will get three product: carbon monoxide, carbon dioxide and water. That is a difference in presence of reagent. Okay. So now I think it is clear. Now let's take the next sheet. Okay. Very important, naming reaction from alkenes, and from alkenes the name is called as a Koch synthesis. Okay. And here it is used to increase the number of carbon atoms by 1. When you have to increase the number of carbon atom by 1, this method is used. Same method we have used in the KCN. When we use the KCN, there also number of carbon atom will be increasing by 1. In the Koch reaction also same. Carbon monoxide and H2O. Okay. So they both will combine and further combine with the CO. Okay. So this I will write it here just like a mechanism. It is only memory technique, not actual mechanism. Just to remember to make the organic easy. Okay. So this is CO. What you will write? H and OH. Okay. H and OH. So this hydrogen will go here. Okay. This carbon will attach here. So then OH will be attached here. So then what it will happen? CH2 and one hydrogen. Then it will form the CH3. As both sides something is added, therefore it will be single bond. Then it will be CH2. Then already CO is there. On that one more OH is added. COOH. That is the carboxylic acid. This is called as a propanoic acid. What it is? Propanoic acid is formed. Okay. So see, we have taken two carbons and we are getting three carbons. So this is also used in which type of series? This type of series is called as, okay, the series in which number of carbon increases, they are called as a ascent series. What they are called as? Ascent series. So this reaction is used in the ascent series. When you wanted to increase the number of carbon by one, then this Koch reaction will be easiest method to convert. Understood? So see here, if you are taking the propene and what we got? Butane or 2-methyl. Understood? So this will be branched methyl. The COH will be attached on the less more degree or less hydrogen containing. This is what they wanted to tell. And what will be written in the presence of H3PO4, temperature is 300 to 400 degrees Celsius and pressure must be very high pressure. Okay. And then next by the oxidation of alkenes and alkynes. Okay. Here this method is restricted only for alkenes and number of carbon atom will increase by 1. But in this condition, oxidation of alkene and alkyne, you will get 2 carboxylic acid moles. So for that, we can use oxidizing agent as HNO3, oxidizing agent as CrO3, or oxidizing agent as K2Cr2O7. Okay. So in this presence, the bond will break. This total double bond will be breaking. And how many oxygens I have written here? 4 oxygens. Out of those 4 oxygens, 2 will be attached here and remaining 2 will be attached here. So RC double bond OH and R dash C double bond OH. So 2 moles of carboxylic acid we will be getting. Okay. But if they both are same, then it is okay. If they both are different, then it is going to be unsymmetrical. Unsymmetrical alkene will give you the mixture of carboxylic acid. And one more important thing, if the double bond is having both hydrogen, so then what it will give? It will give you the CO2 and H2O. Okay. If it is having CH, okay. If it is having CH like this, sorry, uh, RCH, but here R is there and double bond is there. So this will be converted. That I will write it on the whiteboard. Okay, see here, if it is RCH, like this it is there. Understood? CH2. Then this will give you the CO2 and H2O. What it will give? CO2 and H2O. Otherwise, I will write it on the right side so that it can be clear to you. Okay? CH2 double bond. Otherwise, if it is one side R, another side it is double bond. Then this will be converted into RCO OH. If it is R, then and R dash and double bond is there. Okay. Then it will be converted to ketone. It will be converted to what? Ketone. R C double bond O R dash. Okay. This is the type of alkyl group. Either see double bond is must once it is alkene. Once it is alkene, double bond is must. If on double bonded carbon atom both are hydrogen, product will be CO2 and H2O. One alkyl group is there, then product will be carboxylic acid. If both alkyl groups are there, then product will be ketone. This is just like a memory technique. Okay. So now let's go back to the slide first discussing about the alkynes. This is oxidation of what? Alkenes. Now we are going to discuss about the alkynes. Okay. So alkynes oxidation, triple bond is must. So once triple bond is there, here we can see triple bond. Okay. So in this triple bond will be breaking and this will be converted into RCOOH. See, for here hydrogen is must, therefore the water is taken. Here hydrogen is not required. Already hydrogen is there, hydrogen is there. Therefore, here water is required. RC is giving RCOH, R dash C is giving R dash COH. Okay. So there is no problem in the triple bond. You will get again same mixture of carboxylic acid. What you will get? Mixture of carboxylic acid. Okay. So let's solve some questions on this type of reactions. Okay. Now write down find products of find products of oxidation of, okay, first thing is but1-ene, okay, second thing is pent2-ene, and third thing is 2-methyl, not this one, I will change this, okay, hex 3-ine, okay, and fourth one but2-ene, okay, plus carbon monoxide, okay, in presence of H3PO4, in presence of H3PO4. Now you can try, okay. Okay, so first question, let us take but1-ene. So that means it will be first carbon only will have double bond. So here it is CH2, here it is CH, here it is CH2, and here it is CH3. So let's see the what condition says. So that CH2 is there, that CH2 is need to be converted into CO2 and H2O. Okay. So because of this, one product will be CO2 plus H2O. Okay. Then another part, this part which condition it is meeting? CH part. So this is it is meeting. Then CH will be converted to COOH. Okay. So the answer will be CH3, CH2. Wherever CH is there, there you will write as a COOH. Okay. On arrow, what you will find already it is given in the slide. Okay. So what is that? Let me check. Okay. Let me show you. So here, this is the on arrow, you will get either HNO3, or CrO3, or K2Cr2O7. Any of the three, any of the three, one will be given to you. You have to identify the product. Now I think it is clear to all of you. So let's try the second part. Okay, first part I have explained you. At least by the explanation, you should be in a condition to solve the question. Okay. So pent2-ene. First, what you will write? Very good following. Okay, total 5 carbons are there. And on second, ene means second and third, there will be double bond. Very nice. Okay, you assume as a oxidizing agent is present. Okay, now I have to fill up what? Hydrogen. CH. Okay, here CH3. Next it is CH. Here also CH2, then it is CH3. So the bond will break like this. Now let's check CH if it is there. If CH is there, that will be converted to COOH. Okay. And here fortunately both side it is CH. So this will be one carboxylic acid. This will be another carboxylic acid. So CH3 COOH, and second thing will be CH3 CH2 COOH. So this is the both carboxylic acid produced. I think it is clear now. Now you can try the third and fourth.